The James Telescope began its exploration. Numerous scientists, such as Brian Cox, have made announcements revealing the true size and vastness of the universe, which is almost unimaginable. Within the fragment of the universe that we can observe, there are approximately 2 trillion galaxies. This estimate is based on the studies of the local universe, the section of the cosmos closest and most accessible to our instruments and observation. Yet, we are quite sure that this portion that we can see is only a small part of what could be an infinite universe that we do not yet know, comprehend, or have the tools to fully explore. We're not separate from the universe, as many might assume, but are in fact an integral part of it. We are, in a way, the means through which the universe knows itself. This idea, poetic and scientific alike, gives our search for cosmic understanding a personal dimension. With the help of the James Telescope, we punch into a vast exploration to discover the true size of our universe, a journey that challenges our imagination and expands our horizons every day. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell so you never miss an update. To put things into perspective, if we were traveling at a speed of 70 miles per hour, a common speed for cars on highways, it would take us about 15 days to complete one lap around the Earth's equator. That's how small our planet is in comparison to cosmic scales. Now consider this. It would take approximately 5 months to reach the Moon, our closest celestial neighbor, at that same speed. Then, an astonishing 63 years would be required to reach Mars at its closest point, and an utterly staggering 4,400 years just to reach Neptune, the most distant recognized planet in our solar system. These figures alone, just within our solar system, demonstrate the immense scale and distances involved. To place this in even sharper context, consider the Voyager 1 probe. Launched in 1977 at a speed of 38,000 miles per hour, one of the fastest spacecraft ever created by humans, it did not leave our solar system until the year 2012. This means it spent 35 years just to get out of our solar system, a feat that shows how truly enormous even our own local cosmic neighborhood is. Even light, the fastest entity in the known universe, which can circle the Earth 7 times in a single second, seems relatively slow when compared to the vastness of our solar system. And although our solar system is indeed vast, it is absolutely dwarfed by the enormity of the Milky Way galaxy. This spiral galaxy, which we call home, contains approximately 300 billion stars. Each of these stars probably has its own planetary systems, just like our Sun does. Our nearest neighboring star, Alpha Centauri, is located 4.3 light-years away from us. That means even if we were traveling at the speed of light, the fastest speed known to science, it would still take us 4.3 years to reach it. Now imagine the time it would take to travel to the next star system, Alpha Centauri, using the current technology we have today. Even if something were traveling at the same speed as the Voyager probe, that is, 38,000 miles per hour, it would take a staggering 70,000 years to reach Alpha Centauri. This statistic alone underscores the sheer immensity of the distances involved in exploring the cosmos. Let us now focus on Volta Rouge, a star located 640 light-years away from Earth. If we consider what we call the radiosphere, this represents the distance our radio transmissions have covered in the last century. Although the signals have degraded significantly over time, they have so far reached about 15,000 star systems. However, this figure is only a fraction compared to the number of stars in the Milky Way, which, as mentioned before, is estimated at 300 billion. And then there is Volta Rouge again. If you look at Rouge in the night sky tonight, you're actually seeing the light that left its surface 640 years ago, which was about 100 years before Columbus set sail for the New World. This light has struggled for all that time and is just now reaching our planet. It is truly amazing to realize that Volta, on a universal scale, is considered relatively close, yet it's still 640 light-years away. To amaze you even more, we must consider that our radiosphere, which encompasses all human radio transmissions over the past century, is only a small dot within the immense expanse of the Milky Way galaxy. To help us imagine this scale, let's use an analogy. If we were to reduce our solar system to the size of a quarter of the United States, then the entire Milky Way would be compared to the vastness of our planet Earth itself. In this immense region, there are about 300 billion star systems and their accompanying planets. We're just one of those 300 billion star systems floating in the midst of an unimaginably large number of stars and planets. Beyond our galaxy, there are at least 1 trillion more galaxies. Yes, 1 trillion. 1 trillion is an incredibly large number. To understand its magnitude, imagine a collection of 1,000 cats. Now suppose that there are 1,000 groups of cats, each consisting of 1,000 cats. That would give us a total of 1 million cats. But to understand a trillion, we must remember that there is already a million represented in that number. So a trillion equals a million times a million, which is a staggering number of cats. But in the context of the universe, that's the number of galaxies estimated to exist beyond our own. Our nearest neighboring galaxy is the Andromeda Galaxy, located 2.5 million light-years away. Andromeda is rapidly approaching us at a tremendous speed. As this galaxy approaches, our night sky will undergo significant changes over the next few billion years. This galaxy contains about 1 trillion stars. When it eventually collides with our own galaxy, the Milky Way, which, as mentioned earlier, contains around 300 billion stars, the chances of individual stars from both galaxies colliding with each other are quite slim. This illustrates the vastness of space and the low probability of direct interactions between stars even during galactic collisions. Interestingly, these galactic collisions, though rare at the level of individual stars, may even facilitate the transfer or emergence of life between stars and galaxies. Galaxies are not static systems, but are dynamic and constantly evolving. As we move further away from our galaxy, we find our local group of galaxies followed by the Virgo cluster, which contains more than 1,500 galaxies. And Virgo, in turn, is part of a larger supercluster known as Laniakea, which contains approximately 100,000 galaxies. Each of these 100,000 galaxies has hundreds of billions of stars and planets of its own. And this is only a small part of the big picture. In the observable universe, there are another 10 million similar superclusters. As we zoom out and observe, we discover an increasing number of mapped galaxies, that is, determined galaxies. However, these mapped galaxies represent only a small fraction of what is actually out there. There are a staggering number of hundreds of billions of galaxies that have not yet been fully mapped. In addition, we must consider the cosmic background radiation, which represents the oldest detectable light in the universe. That is the residual heat left over from the Big Bang. This radiation is a remnant of the early stages of the existence of the universe. The scale of the universe becomes even more staggering when we consider the vastness beyond the galaxies. We find regions in space known as cosmic voids, where matter is scarce compared to the rest of the universe. These cosmic voids are immense, spanning hundreds of millions of light-years in diameter and appearing as vast expanses of seemingly empty space. However, these cosmic voids have the potential to give rise to the formation of future structures and galaxies. As we move deeper into the cosmos, we encounter cosmic filaments. These are colossal threads composed of dust, gas, and dark matter that stretch across billions of light-years, connecting galaxies and galaxy clusters. These cosmic filaments form a cosmic web-like structure that binds the universe together through gravitational interaction. The distribution of matter in the universe is not uniform but shows a cosmic web pattern where clusters and superclusters of galaxies are connected by this cosmic filament. This creates an intricate tapestry that spans unimaginable distances. It is within these cosmic filaments and superclusters that galaxies congregate, interacting through gravity. The vastness of space offers a vast and abundant stage for the existence of countless celestial objects and phenomena. For example, supernovae, which are the explosive deaths of massive stars, disperse heavy elements throughout the cosmos, enriching the interstellar medium and planetary systems. Black holes, with their immense gravity, play a determining role in the evolution of galaxies and can release jets of energy that extend great distances into space. In the depths of space, we also find exotic phenomena such as quasars, which are supermassive black holes that feed on intermittent matter and emit colossal amounts of energy. These quasars can eclipse entire galaxies and act as beacons of the early universe, allowing us to study the cosmos in its early stages. The question